In this section, we're going to discuss precedence. When an expression is evaluated, its operands and operators are reduced or evaluated to a single type and value. The compiler generates code to perform this reduction or evaluation. This process is the result of an expression which is more complicated than a single value. To ensure that a given expression is properly evaluated exactly the same way every time, there must be rules to determine which operators are processed first, second, etc. This is the point of precedence. If multiple operators of the same precedence exist consecutively in an expression, their order must be determined. This is associativity. We know these rules from algebra. The precedence chart in Appendix C shows the order of evaluation for operators from different groups. What we will find are there multiple groups, such as the multiplicative operators, which include multiplication, division, and modulus, or remainder, additive operators, plus and minus. We're familiar with those from algebra and have an intuitive sense of how they work. Many other operators are not intuitive until you've programmed for a while. Then they become second nature. As we learned from algebra, multiplicative operators have higher precedence. That is, they are evaluated before lower precedence operators such as the additive ones. And also from algebra, we know that if an expression or a sub-expression is contained within parentheses, that is evaluated before other operations outside of the parentheses. Also in Appendix C is a list of the associativity rules for operators within a given precedence group. The most common ones are the arithmetic operators. We're familiar with this. And assignment operators. Arithmetic operators have left to right associativity. What this means is that if a series of operators of the same precedence level are in a sequence, we resolve them or evaluate them left to right. For example, 3 plus 4 plus 6 is evaluated by taking the 3, adding to it the 4, the result being 7, and to that, we add 6, the result being 13. The order is left to right. Precedence is when the operators are in different groups, such as 3 plus 4 times 6. Because multiplicative operators have higher precedence, we evaluate this by multiplying first. We take the 4. With it, we multiply 6 and come up with the answer 24. Then we bring the 3 down, and to that we add the 24, and result is 27. The precedence and associativity rules ensure that expressions are evaluated identically regardless of which machine or which time the program is run. It always is done the same way. This one would be higher to lower. Different than arithmetic operators are the assignment operators. They have left to right associativity. The reason is, in an expression, if we have a variable, we would not want to evaluate r assigned 3, then to that add 4. That would not work. That's not what we intend. What we must do is first do the right-hand side, evaluate the 3 plus 4, result being 7, and then assign that to the variable, in this case r. So the associativity of assignment operators is right to left. This means we can also do chained assignment. For example, r assign m, which is just a different variable, assign 3. This would take the value 3, which is a single value, type implicitly as integer, and assign it to m. So m now would have the value 3. This is an expression whose type is integer, value 3. That would be assigned to r. So r now would have value 3. In this way, you can assign the same value to multiple variables. However, we generally frown upon it in our standard Java usage because it doesn't bias a lot and it may be confusing. Better would be to say R assign 3 and M assign 3 or M assign R. Here are some examples. In the first one, we do the division first because for div 5 is integer, we in fact get the value 0 because 5 does not go into 4 any times, but it does have a remainder of 4. This would be 4 div 5, result 0, 3 plus 0, answer 3. Second line is all about associativity. Is left to right. 3 plus 4, result 7. 7 plus 5, result 12. The third line down, 3 plus 4 div 5 plus 6, again, the multiplicative operator, in this case the div, occurs first. 4 div 5, result 0. 3 plus 0, result 3, plus 6. 3 plus 6, result 9. The final line is one of associativity again, because both operators are in the same precedence group. They're both multiplication. Therefore, we would do 3 multiply 4 to get 12, and then multiply 12 by 5, result 16.